Students, in previous lecture we have seen Euclid's algorithm and their examples to find GCD of two numbers and find values of m and n such that d is equal to ma plus nb. Right now, in this lecture, we will see another example for finding GCD and for finding values of m and n for your better understanding. Let's see the example. Find GCD of 3587 and 1819 and express it in the form 3587 m plus 1819 m and find two distinct pairs of values of m and n. So first find out the GCD of the given two numbers, which is 3587 and another number 1819. So let's see the GCD of these two numbers. Now here in these two numbers, so 3587 is greater than 1819. So we will apply division algorithm between these two. So 3587 is divided by 1819. So let's see the solution. We have division algorithm. So we will divide this number by this. So 3587 is divided by 1819. So what will be the quotient when divided by 1819? So 3587 divided by 1819. So I get remainder which is less than what? 1819, because our division algorithm theorem says if b is equal to aq plus r, where b is the a and b be any two non-zero, here a and b be any numbers where a is non-zero, then a divides b, right, and r is the remainder on condition r is 0 less than equal to r, which is strictly less than always a, means our remainder is always positive, right? Here r greater than 0, so remainder is always positive and which is less than the divisor 1819, right? So what will be the quotient? So the quotient will be, if I take quotient 2, then their multiplication is 18 into 2, 3 6 something like this, right? So 3587 minus this, so I will get remainder is negative, right? So I want remainder is always positive, means I will take quotient is 1. So after that I will get here 1 into multiplication 1819, so their subtraction will be 1768, so which is less than 1819, right? So the quotient is 1 plus remainder 1768. Now again apply division algorithm between these two numbers. So we will divide 1819 by 1768. So let's see what happened. 1819 will divide by 1768. Now again quotient is 1, because if I take two quotient, then this value is greater than this, so in this case remainder will be negative. So we want remainder positive, so I will take quotient 1, right? So taking subtraction, so 1819 minus multiplication of these two, so we will get the remainder will be 51, right? So subtraction of these two number remaining 51. Now again we will apply division algorithm between these two. So 1768 when divided by 51, so 51, so what will be the quotient? So quotient will be 34. So 1768 minus 51 into 34, so the remainder should be 34. Again we will apply division algorithm between 51 and 34. So 51 when divided by 34, so quotient will be 1. If I take quotient 2, then their multiplication should be what, 68. So here 51 less than 68. If I take 68, then remainder should be what, negative numbers, right? So in this case we get a remainder negative, so I want remainder always positive, so I will take quotient 1. So 34 into 1, 51 minus 34. So what will be the remainder? 17. Again apply division algorithm between 2. So 34 when divided by 17. 17 into 2, right? 17 into 2 what? 34. 34 minus 34. So remainder is 0. Here I get 0. So exact above value of 0 is 17. Therefore what we say? Therefore GCD of number 3587 and 1819, which is 17, right? Now here what we have given, and express it in the form of 3587 plus 1819 n. So we know that, so this is value of d. So what we have, d is equal to always what, ma plus nb. So we will express this in the form. So what is value of d? D is GCD of two numbers, which is equal to ma. So m into a, value of a is 35. So I will write here a is 3587 and b will be 1819. So I will write 3587 m plus what, 1819 n, right? Now we have to find two pairs of values of m and n. Now we have, so I will write, so our GCD is 17. So this is equation number 1, this is equation number 2, this is equation number 3, and this is equation number 4. So using this equation, so using the remainder values and using back substitution, so finally you get the equation 3587 into m plus 1819 n, which is equal to 17. Then we will get values of m and n, right? So from equation first, so we have the value 17, right? Now we will solve this equation for value 17, and using back substitution we will get final equation in the form of like this. Then we will get values of m and n. So from equation 1, what we get, 17 is equal to what, 51 minus 34 into 1. So I have used this equation. Now use this equation means using value of 34. So value of 34 is, so 51 minus value of 34 is, so this using remainder values only. So 34, value of 34 is 1768 minus 51 into 34 and into multiply 1. So this is value of 34. So this is from what, from equation 2. So I have used again two equations. So after multiplication, this 51 minus 1768 into 1. So minus plus 51 into, so 34 into 1, which is 34. So here 51 is common. So I will take 51 common. So into bracket what will you get? Here multiplication is equal to 1. Here is multiplied by 1 and here is multiplied by 34, right? So I will take 51 common. So remaining number 1 plus 34 minus 1768 into 1. So we get 51 into 35 minus 1768 into 1. Again we will use this equation for value of 51. So value of 51 is, what is value of 51? So 51 is 1819 minus 1768 into 1. So using this equation, so you will get, so left hand side is 17. So value of 51 is, 1819 minus 1768 into 1 and into multiply by 35. minus 1768 into 1. So we can multiply only these numbers. So first number is as it is. So here multiply this. So I will write 1819 into 35 minus, so multiplication of these two. First number as it is, so multiply only these numbers. So 1768 into 35, so minus 1768 into 1. So these two numbers are common. So I will take common 1819 into 35. So I will take minus 1768 as a common. So in bracket remaining, here is 34 and here is 1. So add, here is plus sign because I have taken minus sign as a common. So here I have used from equation what? From what equation? 3. From equation 3. So I get this equation, right? So here value 1819 into 35 minus 1768 into 36. Now again I will use equation number 4. What value I can use? 1768. So again from equation 4, what will we get? Which is equal to, so value of 1768 is 3587. So 1819 into 35 as it is minus, so here is value of 1768 is 3587 minus 1819 into, so sorry, here this is from equation 4. So I will write here 3587 minus 1819 into 1 into 36. So which is equal to 1119 into 35 minus, I will multiply, minus 3587 into 36 minus minus plus 1819 into 36. So this 1819 is common. I will take common 1819 into, so this is 35 and plus 36, right? So minus 3587 into 36, so which is can be written as 1819. So addition is 71 minus, or I will rearrange this. So I will write minus sign in internal bracket. So plus 3587 into minus 36. So this is 17, and our equation is 3587m plus 1819n. So I will rearrange this. So I will this number as first 3587 into minus 36 plus 1819 into 71. This is value of 70. So after calculation you will get values 17. Therefore what will be the value of m? Therefore here after comparing these two equations, so comparing these two equations, value of m is minus 36 and value of n is 71. Now what we have asked here, to find two distinct pairs of m and n. Now to find another pair. So for another pair we have the equation here. What is value of a? A is 3587, and what is value of b? B is 1819. To find another pair, so and here we have the formula. We know the formula to find infinite pair. For infinite pair, so what is the formula? D is equal to a into m minus kb plus b into n plus ka. So here we have the values of m, n, a and b. So k belongs to what? Set of integers. So we have to find infinite values of pairs of m and n by using this formula, and d is the GCD of two numbers, right? So using this value, so d is equal to what? 17, right? So we get 17 is equal to value of a is 3587 into m. Value of m is minus 36 minus k into what is value of b? K into 1819 into k plus b into, so value of b is 1819 into n, so n is 71 plus a is 3587 into k. So for k belongs to what? Set of integer. If I put values of k from set of integer, then I get infinitely many solutions of that pair, right? Now I will put k is equal to 1. Put k is equal to 1. Then what will we get? 17 is equal to 3587 into, so minus 36 minus 1819, so the addition value of k is 1, so addition of these two minus 1855 and plus 1819 into 71 plus 3587, so value of k is equal to 1, so the addition will be 3658. So after using the calculator, you will get answer is 17. So this is another pair. Here m is equal to what? Minus 1855 and here n is 3658. So for using values of k belongs to set of integer, then we can find infinitely many values of m and n. Here I have put k is equal to 1, then we get these values. So our first pair is m is equal to minus 36 and n is equal to 71, and second pair is m is equal to minus 1855 and n is equal to 3658. Now let's see another example. If a, b, c are integers such that a divides bc, and GCD of a and b is equal to 1, then show that a divides c. So we have given three integers a, b, c, and what we have given? A divides product bc and GCD of a and b is equal to 1. Then we have to show that a divides c. So solution. So given what we have given, a, b, c are set of integers and a divides b into c. Also what we have given, a GCD of a and b is equal to 1. Then by GCD theorem, what we have, suppose if we have d is equal to GCD of a and b, then there exists value of m and n belongs to set of integers such that d is equal to ma plus nb. We have this theorem. So using this theorem, so there exists m and n belong to set of integers such that, how to exist, 1 is equal to ma plus nb. So here we have given a divides bc, means what? Also a divides bc, then by using definition of divisibility, what we get? B into c is equal to a into k for some k belongs to what? Set of integers, right? So value of bc is equal to a into k. So we will multiply throughout by c in this equation. So what will we get? We multiply both sides by c. So what will we get? C is equal to m a c plus n b c. So value of bc is a into k, but b into c is equal to a into k. So in this equation, what we get? C is equal to m a c plus n into, value of bc is a into k, so n into k. So I will take a as a common in this equation. So I get a into mc plus n k. So c is equal to this. So I will write this as integers, because here MC and K are all belong to set of integer, then MC into, so M into C plus N into K, which will I will write A into K dash. So see where K dash is equal to M into C plus N into K also belongs to set of integer. Then by using definition of divisibility, what will we get? A divides C, hence the true. Let's see another example. Let A and B be non-zero integers, and let D is GCD of A and B if A is equal to dx and B is equal to dy, then show that GCD of x and y is equal to 1. So solution. So we have given A and B set of integer, and D is the GCD of A and B. So if D is GCD of A and B, then by using GCD theorem, what we have? There exists M n belongs to set of integer such that D is equal to MA plus NB. So we have the value of A is dx and value of B is dy. So and A is equal to dx, B is equal to dy. So substituting these values in this equation, we get D is equal to M into, so dx plus N into dy. So D is common, so throughout divide by D we will get 1 is equal to mx plus ny. So here m n belongs to set of integer. Then by using GCD theorem, what we say here? 1 is equal to GCD of x and y, right? It means if D is equal to GCD of AB, then we write it as D is equal to MA plus NB, and if we have D is equal to MA plus NB, then we can write D as GCD of A and B, means this is if and only if condition, right? So we get here 1 is equal to GCD of x and y, means GCD of x and y is equal to 1. Let's see another example. For any integer x, show that GCD of A and B is same as GCD of A B plus A x. So we will prove this. GCD of two numbers, so GCD of AB is same as GCD of A and B plus AX. Solution. Now let us assume that GCD of A and B is equal to G, or GCD of A and B is equal to D, and another GCD of A and B plus AX, which is G, and finally show that both GCD are equal. So let us assume GCD of A and B is equal to D, and GCD of A and B plus AX is equal to G. Since D is GCD of A and B, means what? D is first common divisor and then D is greatest common divisor, right? So D is common divisor means D divides both integers. So D divides A and D divides B, right? So since D is equal to GCD of AB, then what we say? D is common divisor means D divides A and D divides B, which implies that, so D divides A, then what will we say? D divides AX for some x belongs to set of integers, right? So then here D divides A, D divides X, and also D divides B. Then what we say? Then by using theorem, we have seen in previous properties, D divides what? B plus X, right? So here D divides A, D divides B plus X. Therefore, what we say that D is common divisor of A and B plus X, right? So that implies, then by definition, we say that, what we say that D is common divisor of common divisor of what element? So a and b plus x, a and b plus x. Hence, so d is common divisor of a and b plus x, means this is common divisor of GCD of a and b plus x, means this value is nothing but g, means what we say, hence d divides g, right? Because GCD of a and b plus x is g, and d is common divisor of a and b plus x, means d divides g. Again, what we have, GCD of a and b plus x is nothing but g. So this is equation number 1. Also GCD of a and b plus x, which is g. Now g is GCD of a and b plus x, means what? G is first common divisor of these two elements. So by definition, g divides a and g divides b plus x. So that implies, then by using definition of divisibility, a is equal to what? G into k1, and here b plus ax is equal to g into k2 for some k1 k2 belongs to set of integers, right? So here a is equal to gk1, and here b is equal to b plus ax is equal to gk2, right? So I have the value of a is gk1, so I will substitute this value in this equation, so we will get, so therefore a is equal to gk1, and so here b is equal to, I will write this on right hand side, gk2 minus x, so value of a is gk1, so gk2 minus a, value of a is gk1 into x, so I will take g as a common, so b is equal to g into k1, k2 minus k1 x, right? So here g divides, here g, a is equal to gk1, and here b is equal to g into k2 minus. So from these two conditions, what we say here, from this condition I get g divides a, and from this condition I get g divides b, means what? G is greatest common GCD of a and b, means g divides a, g divides b. So g is common divisor of a and b. G is common divisors of a and b. So g is common divisor of a and b, and we know that GCD of a and b is d, means g divides again d, which implies g divides d, because d is common divisor of a and b, right? Greatest common divisor, and g divides d. So this is equation number 2. So here d divides g, and here g divides d, means what we say. So from equation 1 and 2, what we say here, d divides g and g divides d. So this number divides this, and this number divides this, means the numbers d is like this, plus minus g, right? Because here 5 divides minus 5 and minus 5 divides 5, right? Means both the numbers are 5 plus minus, 5 is equal to 5, or minus 5 is equal to minus 5, means here what we say, d is equal to plus minus g, but GCD is always positive, means what we say, d is equal to g, and d is nothing but GCD of AB, that implies GCD of AB is same as GCD of a and b plus ax, hence the proof. Now in next lecture we will see LCM, which is least common multiple of two numbers. Thank you.